Hello everyone, my name is Anshul.
I'm Tanish.
And I'm Anirudh, and this is our product, DeepVision, Securing the Future. We're targeting NGN Goal 17, safely integrate AI and robotics into society, and NGN Goal 9, building a non-violent and tolerant society using a STEM solution. We're from Dublin High School and Fallon Middle School in Dublin, California.
So what exactly is the core problem that our project is trying to tackle? In 2018, approximately 2 million crimes were committed in the US, with over 75% of them being violent and assaultive crimes. Now, this is very important because it influences numerous groups of people in their day-to-day lives, right? Like when they're going to school, when they're going to work, or if they're just going to any other public venue such as Walmart and Target. This has to be addressed immediately.
The solution, DeepVision. We start off by detecting anomalies, then we detect weapons and damage or threatening people in the clip. Then we use our super resolution GAN to create a high resolution video from low resolution security footage. And within 30 seconds, we aim to provide a threat summary to the user.
So as developers, we are going to be convincing you guys as investors that our project is worth $100,000. Now we have a quick demo for you guys.
So our anomaly detection OD model. So here, as you can see, a normal person doesn't trigger anything. And here as a threat, the anomaly detection fires up and the object detection localizes on the aggressor. And we use a super resolution GAN to convert low res video to high res. On the left is low res, on the right is high res. This nullifies the need for high quality hardware for high quality video footage. It makes our system scalable because it isn't dependent on hardware, and also makes our system cheap and completely software based.
So this is our GCP pipeline. As our machine learning clusters run in the background, operating on the video footage and detecting threats, threat summaries will be pushed to the user's device using Google Cloud Messaging. And then the user should receive a notification on their phone or device notifying them of the threat that has been detected.
So if you guys can look at my camera real quick, we have a Raspberry Pi module as well as a camera module. And this was our initial plan for the hardware component, but due to COVID-19, we weren't able to integrate this into our entire system. So now, in addition to everything that we've talked about so far, we also developed a mobile app that ties everything together. And as you can see over here, the mobile app allows business owners to effectively record video clips and see exactly where a threat is happening. And this can allow them to quickly and efficiently notify authority figures such as the police and almost instantaneously deal with the threat.
So the financial breakdown of the $100,000 is majority the GCP hosting cost, which is $75K. Further prototyping costs for $10,000, where we finalize our design and clean it up. Production costs will be $10,000 to set up the supply chain and production, and marketing for $5,000, which will be getting our name out into the market.
So the first part of our sales and marketing plan will be licensing our software as a service to other camera makers. So for 10,000 customers, we'll be getting $5 per month from each person, either from hardware sales royalties or from the user subscribing to our product. We account for $600 of storage for cloud footage, $344 for anomaly detection, $344 for object detection and the super resolution GAN, $2,000 for cloud redundancy, $20,000, which goes towards streamlining our product further, $5,000 in other expenses, leaving us with around $22,000 of net revenue monthly.
So phase 2 of our sales and marketing plan includes all of the different factors that we've mentioned in phase 1. But in addition to that, we also have a hardware component. And as you can see on the graph over here, the hardware sales portion makes up the majority of our net revenue due to the fact that we have a constant stream of income since it's very appealable to the consumer base, the customer base, right? The reason that it's really appealable is due to the fact that the camera itself is $15 per piece. And this is really inexpensive compared to other competitors such as Bring or Nest. And the reason that it's so inexpensive is because we don't have any high-level computers on the camera itself. since all the processing is done on the cloud, right? So there's no need to have a powerful computer on the camera, which allows us to reduce costs extremely. And as you can see over here, we are left with approximately $95,000 per month in net revenue after all of the deductions if we have a customer base of approximately 20,000 people. Now, as I said before, we're going to begin by licensing the software system out to different competitors in the security camera market. Now, this is a very important part about our business plan because we aren't actually competing within the security camera market, right? We are providing our services to all of the competitors in the security camera market who are competing against each other. Now, over time, we're going to be contacting angel investors, CEOs, sharks, and eventually venture capitalist firms to build up enough capital to get into phase 2 of our sales and market plan, the hardware portion of it, right? And once we have enough capital, we can hit mass production and actually compete within the security camera market as well. Now, once again, we're going to be targeting the entire market, but in addition to that, we're also going to be targeting a whole untouched market that artificial intelligent security cameras have not reached yet, public security, right? Because companies such as Ring and Nest, they're all focusing on personal security in homes. And we don't really see any artificially intelligent security cameras out there in the public that can recognize public threats, people holding guns, people fighting, and stuff like that. So we are literally targeting an entire market that already exists and focusing on a completely different market, public security, in phase 2.
So our competitors include Google Nest and Ring. So their strengths are that they have a widespread ecosystem of smart home products, provide paid monitoring services, and have high quality footage. However, the monitoring service only detects unknown persons, and it's easy to fool with a hood and has many false positives, which can annoy the user. These systems are also very expensive, with $120 per camera and $10 a month per camera. Opportunities here are that Google Nest are potential buyers of our product. Since our system is completely software-based, it just builds off already existing cameras and other systems. Threats here are that the idea can be replicated if we don't handle all legal paperwork and patenting.
So in summary, there are millions of crimes committed in the US every year. So our solution is an end-to-end software service pipeline, which will give us a constant stream of income and allow us to capture the entire market with virtually no competitors, as we're undertaking home security camera makers, and we're also taking on a whole new market of public security as well. So therefore, I believe that we have convinced you that our project is worth $100,000.
Thank you so much for listening. Do you guys have any questions?
Hi.
So I'll jump in with one. Oh, go ahead.
No, go ahead.
So my question is, what's your plan for the training data for your machine learning?
So currently, our training data was online data for, say, security cam footage that was already pre-available. And it was pretty basic and pretty limited, where it was maybe a hallway where the anomalies would be someone walking by or someone doing something they weren't supposed to. And for the object detection, there was not a lot of data is needed. You can manually annotate maybe 100 images, and using the power of pre-training neural networks, you can use the object detection API and get reasonable accuracy.
Hi, guys. Go ahead.
Go ahead. Okay, just one follow on then. So I'm confused as to the differentiation between Nest and Google. What's your advantage versus their approach?
Okay, so the thing is, right, our system itself is a software-based system. Right now, Google Nest and companies such as Ring and Wise, they are focusing on producing like hardware components that are being bought by different people. So the thing is, we're not competing against these people yet, unless we move on to phase 2. We're actually providing our software services, right, with all the object detection, anomaly detection, SRGAN to them, right? And this basically nullifies the fact that we're not going to be competing in the market, but we're going to be providing our services to the entire market. We're competing against each other, the individual companies competing against each other.
Mark, go ahead. You have a question?
Thank you.
Yeah, the threat detection you're primarily looking for are they carrying weapons? Is that correct? And I have a follow-on then too.
Yeah, so it's weapons and anything if they're doing that isn't supposed to happen in that area.
Okay, so do you sort of anticipate first it's going to be applied on the public side, as you indicated, like at schools and that type of thing, or
Yeah.
where are you? Okay, thanks.
Robert, you have a question?
Yeah, just a couple of questions. Still trying to understand a little bit in terms of how you define something as an anomaly, right? Is it strictly weapons? I mean, do you make a distinction between, for example, knives versus guns? Do you make a distinction between making bullying statements, or help me understand, how do you define something that's an anomaly?
So the way we would define an anomaly is, an anomaly would basically be anything that seems to be like what's not supposed to be happening in that area. So that can encompass everything from like guns to bullying statements. But then we use our object detection to further narrow down on what exactly the specific situation is in that case.
So adding on to what
Yes.
the way the anomaly detector works is that it's trained on all of a bunch of data that's already like supposed to be calm and there's not many anomalies going on. And what happens is when the model outputs something that's unreasonably different, then it recognizes that as an anomaly, and then based off of that, it fires the object detection in that specific moment of time to be able to detect what exactly the threat is.
So just a quick follow-up on the on your, let's say use the example in schools. Let's say there's a conversation before let's say a fight happens, right? So are you detecting the issue where the conversation had a heated conversation and then resultant in a fight and calling that an anomaly? How do you distinguish what is the anomaly, and can it be used as a preventive, maybe a preventive mechanism?
So the thing here is that based on the nature of how we do the anomaly detection, how it functions is that we train it on a bunch of normal data. So for a school would be people walking by, people playing, people talking with each other. And what happens is that when the model sees something that's out of the picture, that's different, say maybe a fight or a bullying incident, then it does poorly on that data as opposed to the normal data, which it's been trained on. So in that way, we're not specifically defining anything. It's what the model trained thinks that is different from the normal situation of the area.